I'll just put it in the notes section here to let people that are coming in. And then the recording, once we're done, will go on a, oh, I like your thumbs up there, Chip. Did you do that? Yeah, I guess so. This will be on the YouTube channel. CARC has a YouTube channel, is that correct? So we will put it out there and we'll start doing that. So a couple of the other tracks are doing that, and I think that's really important. Not everybody can attend.
Do we want to take a second, Jane, and call for facilitator interest for our upcoming calls here at the top of the call? So we had talked a little bit about.
Thank you for those who filled out the survey that we sent out. I haven't checked the responses. We're going to take a look at it here in a minute, but appreciate that to try to get an idea. It seems like we're all pretty much interested in the same things or similar. So it probably depends on where you are in the development of your center. I'm developing mine. Actually, we just got notice yesterday after 18 months that the Office of Research is going to make our initiative into a core research facility. So that's very good because there will be some support and subsidization that we didn't know if we'd have. Hey, Brian. One of my Ohio supercomputer friends is on. Do you want to maybe, since we have a smaller group, I think it'd be nice to go around and kind of introduce everybody, or everybody introduce themselves. What do you think, Rich? Okay. I never know how to start the. You know what I'm going to do is I'll go down the list of people that have signed in. Kirk, you're first. If you'd like to just tell us who you are, where you're from, and maybe what status your center is in, or what it is that you're maybe looking for.
Yep. So my name is Kirk Ann. I'm the
You're
director.
Muted.
Am I back now?
No, I can hear Kirk.
Yep.
Jane, can you hear us?
Okay.
Still can't hear you.
My name is Kirk Ann. I'm the director of research computing at RIT.
Is it just me, or can everybody else hear him?
I can hear.
Yeah, go ahead, Kirk.
Right, it was me. Oh my God. Sorry.
Just checking.
Okay. Go ahead, Kirk.
Time's a charm. My name is Kirk Ann. I'm the director of research computing at RIT. We've had a research computing there for a while, since like 2000. However, this is a rebirth, and I was brought in on December, so we're about a year into our rebirth, and actually got some allocations, staff allocations and hardware allocations, but still working on policy, working on actually getting an operating budget versus the one-time shot and things like that. And our favorite word of the day is 171.
171.
800-171 compliance.
Oh, yeah, right. Yeah, good. I'd like to know about that. All right, Chet.
Well, I'm Chet Langen from Southern Illinois University, Carbondale. I work for Central IT, and the university provides through us a small HPC cluster for all the researchers at the university. So I have a small staff with a couple of graduate assistants, and we manage applications for accounts on the cluster, and we give new user training on how to log on and submit jobs, and we monitor the cluster, and we help with data transfers, installing software, and that sort of thing. We work with quite a few different departments at the university, from engineering to math to computer science to biology, just to some others.
Good. I'm Jane Combs, University of Cincinnati, and I kind of mentioned where I'm at. And we just put in 20 more nodes, and we're up to now a whopping 56 nodes on our cluster, serving about 100 faculty. And we have what we call a volunteer staff of people that are interested, and we're trying to get continued funding, but I think we kind of got that. Okay, Strahinja?
This is the Untitled Chapter from New Mexico State University. I'm a system admin here for our HPC, and I'm here to learn more, to hear what you guys have to say. Nothing special, but yeah.
Good, thanks. Sarvani?
Hi, everybody. I'm Sarvani Chadalpaka from University of California, Merced. I'm HPC manager there, and right now I am the only one FTE for research computing in our whole university. We are over 2,500, 3,000 core cluster, and we've had research computing for a while now, from 2016-ish. But then just now is when we ramped up the process to set up a dedicated HPC center, to have dedicated budget and everything. So really, I'm interested in learning about all the steps in the process, from budgeting to developing policies to everything in between. So I'm happy to learn from this group.
Richard Gilmore.
I'm Richard Gilmore from Colorado School of Mines. I've been a user on the HPC system since inception, well, part of inception for our first cluster in 2011. We've been through a couple of retired old systems, and now we're up to trying to manage 3 or 4 clusters, and it's becoming a large headache for all of us. We're a team of 4 people, 3 people hiring 1, hopefully next couple of weeks. We're trying to implement some policies that are a little more challenging and a little scared about doing, and don't want to rock the boat within our researchers. So it's been interesting.
Let's see, Neil. Neil is our guest speaker today, so I can kind of introduce him there, but he'll introduce himself here. Go ahead,
Sure.
Neil.
I'll just do a quick one for the moment. I'll save the rest of it for the talk.
Okay.
Neil Bright, Georgia Tech, and I run our HPC center.
Awesome. Rich Nepper.
Hi, I'm Rich Nepper. I'm the Deputy Director at Center for Advanced Computing at Cornell University, and we've got an on-premise cloud resource that we use to support Cornell faculty. And I help organize some of these talks on a monthly basis. So, thank you.
My co-chair. Justin Booth from Michigan State.
Hello. Yes, Justin Booth from Michigan State University. I work in central IT, but we have just created a new department called Research Cyberinfrastructure. We do not manage the HVCC. That's a separate research unit on campus. So what we're attempting to do with this new department is coordinate and collaborate with all the different research units on campus. And so we're really trying to build standards and policies that support and fill some gaps that are there. So some of the things that we're focusing on right now is kind of a research facilitation network, trying to develop intake process and a consulting process, trying to also connect the security, information security policy with the actual technologies that we have. So we've been kind of building off of the Cornell Data Finder for MSU. And so we took that template and we're trying to walk security through the needs of the researchers. And so we're kind of doing that and we're getting real close. That's been an interesting process. And now we're trying to focus on data management solutions and how we can't do a better job of collaborating across there. And so really the word is, I have very few staff members at the moment, but trying to understand how we can build this up in a way without duplicating something that's already been done in the research space. Thanks.
Sounds familiar. Okay, Chip Eckert.
Hi, I was the CIO at UW Eau Claire for about 14 years, and I moved over recently to take over high performance computing group, I guess, if you will. We've had a cluster for about 9 years, totally managed by students. There's no FTE behind it other than students. We recently won a grant. Some of our faculty did. So right now we have 380 core, but this new cluster will have 4,600 cores. And I think I know it's going to be one of the selling points of our campus. We already have people from 6 other campuses use time on the system. And I'm just trying to get a handle where we have very few procedures. We've got good documentation for what we have, but it's like trying to drink from a fire hose right now.
Good problem to have, maybe. All right, let's see. Tony Elam from University of Kentucky. We're getting more people on here, which is good, but I don't want to take up too much more time, but let's hear from everybody.
Yeah, hello, my name is Tony Elam. I'm the Associate Director for our Center for Computational Sciences. And our center is now in its 4th year of a emergence, a revitalization. So Dr. Jim Graffoon became the director a few years ago, and he and I have been making major advances and changes in growing our center.
Yep, you have. Great. Claire Mizumoto.
Hey, everybody. I'm Claire Mizumoto from the University of California, San Diego. I'm the Director of Research IT Services. We have a fairly new research cluster that is part of a bigger environment that includes an instructional cluster. And so I'm super interested to listen into this community to hear what y'all are doing and how you are handling your emerging centers.
Okay, Horst from Oklahoma.
Hi, yeah, I'm a research computing facilitator at the OU Supercomputing Center. So I'm one of Henry's minions, and yeah, we have the cluster has been the center has been around for quite a while, since 2002, I believe, and we have about 20,000 cores now. So we're doing pretty well.
Brian Gilfoos from High Supercomputer Center.
Okay, there we go. So yeah, my name is Brian Gilfoos at Ohio Supercomputer Center. We are not an emerging center. We've been around for a very long time, and we're going to be up to 52,000 cores later this summer. But we work closely with Jane, and I actually enjoy these kinds of conversations because I think we can all learn a lot from each other. So coming here and actually policy development is something we're wrestling with right now. So I'm interested to see what we all have to talk about.
Good, great. Jeff Dusenberry, University of Massachusetts, Boston.
Hi, so I'm Jeff Dusenberry, UMass Boston, Director of Research Computing there. The department's been around for about 7 years. I have one full-time equivalent, and so it's just the 2 of us. 45 nodes on campus, small clusters. We do broker access to 13,000 cores shared by the whole University of Massachusetts system. I guess we are still kind of an emerging center. We have governance attempts in the past that have failed, and so we're just trying to restart now. We were actually in the process of doing that when COVID-19 hit, so we postponed that, but that's where we are.
That's great. Jayshree Sarma from George Mason.
Yeah, ours is an emerging center. It started out in 2013, started out as a facilitator, 1 FTE, and kind of slowly growing the office right now. We have a 1,600 core HPC cluster, and we're planning on building a new one. And we're trying to still recruit facilitators and want to come up with policies for the new cluster. So that's one of my reasons for joining this, to learn from you all.
Yes, great. Good. George Scherner, IU. Hi, George.
Yeah, I'm Indiana University's Chief Systems Architect. I work with the systems group. Indiana University has had a long history of supporting research computing, and I'm here to help however I can with the emerging centers.
Great. And George helps me a lot, as he's our grand poobah, I guess we call him, advisor. Patrick Clemens, University of Vermont.
Yeah, I'm Patrick. I manage the cyber infrastructure for the Vermont EPSCoR research program here. So I work closely with the university central IT. They manage a lot of our systems for us, and I just make sure that our researchers have the compute they need to get their work done.
That's how that goes. And Lisa Lowe from North Carolina.
Hi, from North Carolina State. We have had a cluster for a long time. It has about 1,000 nodes, over 100,000 cores, and we don't have enough staff. We've never had enough staff, so I am trying to figure out, where does one get money to hire staff? So that's it.
Yeah, consistent problem. Okay, Liam just came on from University of Alaska. Probably the only cool place in the state or in the country.
I don't know about that. But yes, good morning. My name is Liam Forbes. I'm with the Research Computing Systems Group here at the Geophysical Institute, University of Alaska Fairbanks. We have a small cluster and several hundred terabytes of luster, as well as several petabytes of tape storage. And we're trying to hire people and expand our group a bit, as well as figure out the right policies for interfacing with faculty and sharing our resources, which are not at this time dedicated for individual projects by any means.
Okay, so I think we're ready for you, Neil, if you wanted to get started on, I don't know if you were going to do a presentation first, and then we were going to go through page. So, and I don't know, Rich, if you had something else you wanted to say. I think we kind of.
No, I think we're good. I think we're good to let Neil rip.
Yep.
Yeah, I just have a couple of slides to keep me on track at the beginning here, but I'd like to spend as much time as we can just kind of answering questions. You know, part of this deck is just to kind of give some context of where Georgia Tech is and how we got here. So with that, let me, can I have ability to screen share, please?
Yes, I'm working on promoting you right now. Okay. You have been promoted.
There we go. Okay, share screen. There we go. There. Let's share that one. Okay, so hopefully everybody can see that. Okay, so first a little more introduction on me. I've been at Georgia Tech here for a little over 22 years. Originally started in one of the departments doing sysadmin type stuff there, and then moved over to our central IT group some years ago and started what has become PACE. Also doing a lot with CASC and LCI these days. Maybe a little bit less with LCI at the moment with, you know, that's all about in-person training workshops. So that's a little bit on hold at the moment.
Hey, Neil, what's LCI?
LCI is the Linux Clusters Institute.
Hmm.
And we put on a couple, 3 workshops a year for about a week that train people in how to be an HPC Linux sysadmin. So
Wow.
we're our typical student is somebody who has some experience being a Linux sysadmin, and we're giving them that, that additional skill set to let them manage an HPC cluster effectively.
Right.
We've got an intermediate workshop. We've got an introductory workshop. We were supposed to have an advanced workshop this year. I think we were going to do that in June, I think, or July. Anyway, that all that kind of got put on hold as people had to deal with their day jobs. LCI is a volunteer organization. So we're going to, at least the steering committee is going to start getting back together here soon and see what it means to translate that into a virtual experience. We still see the need for, for this kind of training out there. We just need to figure out how to deliver it effectively in the virtual format. So CASC is Coalition for Academic Scientific Computation. Really, this is a group, longstanding, it's been around about 30 years, of center directors. A couple of people on this call attend a couple of meetings a year. We do advocacy, we do outreach to the federal funding agencies, NIH, NSF in particular. We've had some presentations in the past about 800-171 and what does that mean, and things like that. The emerging centers are absolutely welcome in that environment as well. And that's something that we would encourage. And that is where I got a lot of the ideas that I used to apply to PACE when we were first spinning that effort up. So it's been at the time CARC didn't exist, 15 years ago. So that was a great place to do it. Now we've got a couple of different opportunities for similar sets of people, but kind of focused on different areas. So that's been a nice overlap. So a little bit about Georgia Tech. These are a little bit old numbers from about a year ago, but they'll suffice for now. Give us a general size and shape of what we're looking at. These are active things. So we're a pretty decent Exceed user as well. We haven't been an Exceed provider yet. I'll come back to that in a minute. Let's see. Some of our new big things, the OSG Grant, we've been calling it. It rolls off the tongue a lot better than the full title of the proposal. But this was done by one of the leaders within PACE. It's actually the physics folks. CRA is our computational relativistic astrophysics, which is a mouthful to say for sure. They actually came to us and said, "Hey, can you PI this this proposal?" So that's a nice thing. That is just about to come online, and we're going to make a lot of those cycles available to OSG and integrate that with our current resources that are being used for LIGO, or maybe the other way around, but that's it. Big thing that we are doing that is getting close to the end of its first year in production. This rather nice MRI award that we were lucky enough to get after many, many years of trying. That is going to be available to exceed. We're working with Indiana on the Science Gateway that we're going to use to do that. So that's just about ready to go into production. Those folks have been really great in helping us get that set up. Just as a side note, since COVID started, we've had a number of Georgia Tech researchers come to us and Srinivas, the PI, say, hey, can I get time on this machine? I've got some COVID-related simulations I need to run. So it was really, really nice to have this resource that we could rapidly deploy for that kind of work. Let's see, some pretty pictures here that kind of tie into the discussion here. So Hive was the first machine that we spun up in a brand new data center. So the picture on the lower left here, you've got the brick building in front, which has been designated as a historical building. So that's going to get renovated at some point as well. The white building that's kind of obscured by the historical building, that's a new data center. It is 10 megawatts capable. And this whole CODA complex is actually a public-private partnership. Georgia Tech owns the land, but we've done a deal to give the air rights to Portman Holdings. So we built the office tower, we built this data center, and then Georgia Tech is an anchor tenant with a lease, long-term lease in both spaces. So right now we've got a hold of 2 megawatts of the data center. And DataBank is operating that facility. So they're also leasing to commercial interests that have some sort of connection to Georgia Tech. So that's been a really interesting, from an economic development kind of story, is that people can, Georgia Tech takes about half of the space in the office tower and the space in the data center, like I mentioned, and other companies can come in and rent space in both that have a connection to Georgia Tech. And the building is designed to be with a very open floor plan and highly collaborative, and coffee stations every couple of floors and all kind of this, and it's been vacant for months. So that was kind of unfortunate, but that kind of ties into what I'm going to be calling PACE 3.0. So to explain what PACE 1.0 and 2.0 were, let me go back in time a little bit. When we first started PACE about 15 years ago, it was, 1.5 FTEs, half of me and one other person that we hired. And we had no official budget. We were literally pulling equipment out of the surplus pile before the surplus truck came to get it. And we cobbled together some things, and we did really kind of a skunk works deal. Then about 2009, we pulled together a group of interested faculty and took a proposal up through our VPR and said we need to do something for campus. At that point, we got some funding for some people, we got some funding for equipment, and that's when we kind of started PACE 2.0. So 2.0 is the model we're operating in right now. This slide here is a slide that I've been using for a decade that really kind of distills this model. At its core, it's a subsidized model where faculty buy equipment and we manage it. So the faculty buy the things that directly impact their work. They buy compute nodes and they pay for storage. And all of the other stuff, so if you draw a vertical line through any of this kind of thing, that's all the stuff that you need to have a cluster, right? So all of the blue stuff, the institute funds via the PACE budget, and the white stuff is what the faculty fund. Getting into some of the nuance here, we have a pool of nodes that are available to be shared that the Institute has purchased as well. We encourage people to share the idle cycles on their resources, but we don't require it. So that's why you get the two kind of stacks in the middle there. And of course, we've left the option over on the far left for people just to go off and do their own thing. We wanted that there in the beginning because we knew we wouldn't get everybody to buy in initially. It wasn't really a build it and they will come kind of model. It was a build it for willing participants, provide excellent service, and through word of mouth, people will come to us. And that gambit was successful. So at this point, we have our entire College of Engineering saying, if you're computational and you want something in your startup package, you must put it in PACE and you must share that equipment as well. So we've been pretty successful. As far as I know, there's only one resource on campus that isn't managed by us. And they're just off, well, one major resource. They're just off doing crazy systems biology stuff. There is also a fair bit of novel architecture type things that the College of Computing does. You know, they're the ones going and doing kernel hacking, and they're the ones, you know, hacking on schedulers, and you know, they're making new tools for the HPC community to use, where PACE is providing a stable set of tools for the other researchers to do their work, right? So, you know, it's kind of hard to run a production facility if you've got people in there hacking on the kernel and all that kind of stuff. So that's kind of where we are now. Going back to this for a minute. PACE 3.0 is coming from a perspective of, now that we have this new data center, we've got something like, you know, 55,000 cores and a couple of petabytes of storage over in our old data center. How do we get out of the old data center and into the new one? And we took a long, hard look at that. We've got a lot of old equipment, some dating back as far as 2011 in the old data center. We knew it didn't even make sense to move a fair bit of that. So when we looked at it and did the math, it turns out it was more cost effective for us to just abandon in place everything in the old data center and buy a whole new set of stuff and put it in CODA. A lot of calculation spreadsheet stuff went into that decision. A large factor was simply the cost of being in CODA. In the old data center, we didn't have quality metrics on what the power cost was. In that, you know, it rolled up to the campus substation, and that's what it was. Facilities that knew how much power campus was drawing, but it was kind of a hidden cost as far as the electricity that we were consuming. so taking that into consideration, where in the new data center we see that cost, it was more cost effective to replace all of the equipment. So that gives us a huge opportunity to retool our model again. And we're moving to a bit more of a consumption-based model, with cloud commercial cloud style pricing, per CPU hour, per terabyte month kind of operation. We haven't gotten that message out widespread within our own faculty, so I'd like to steer most of the conversation towards PACE 2.0, where we are now. I guess I should have prefaced this whole talk with, I'm happy to have conversations with anybody that wants to know more. I'll have my contact information is already in the meeting document, so please don't hesitate to reach out. Happy to set up another call and go into detail on anything you might want to talk about. That's fine. So let me leave it there, and we'll have some more time for questions. What do folks want to know about? I'll just kind of leave it wide open.
Thanks, Neil. I have a quick question. Do you have a list of policies and acceptable use documents that you share with your faculty partners or with your user base somewhere where we could access, just so we can take a look at them?
Yeah, there's a couple of things that I will point you to. If I can figure out how to stop sharing. Oh, there it is. In the chat, I will put that page. And I will also put, so there's a policy page and a participation page in there. Those are a couple of things that I would point you at. Let's see.
In the survey, maybe, the number one things that people wanted to kind of talk about the policies were process for new accounts, or what's the agreement between, we called it user life cycles. So do you have an MOU, software installation, data storage, and scheduling policies? So maybe we could look at those on the PACE policy page, or see how,
Sure.
kind of what you guys did. And we at UC, our faculty leader came from Georgia Tech, and so we basically are taking PACEs and list on that website, and looking at them and modifying them, and looking at others and modifying them. But do you want to share that?
Sure. So I can,
page.
Yeah. The policy page is I stuck in the chat.
Okay.
Some things to highlight out of there. I guess the first thing on that policy page is a procurement cycle. So what we have been doing in the past is faculty spend equipment money. That equipment money does not get the F&A overhead charge put on it. So that has been very attractive to the faculty, and has been very straightforward model to work with. However, that's become a real challenge as we're a state school, right? So we get all this stuff from the state, and there's been some public ethical problems related to purchasing at Georgia Tech in the last year or two. Not within my group for sure, but broader within the campus community. And that has really caused some additional steps required for large purchases. So where we had been doing, 4 or 5 orders a year, it now takes us between 6 and 8 months to get a single order through. So probably more than anything, between this and the move to CODA, we just have to change our procurement policy. And that's a lot of where that cloud style model came from. So we're kind of decoupling that faculty needs resources from we go buy stuff. And that way we can provision the faculty a lot quicker, days kind of deal. Maintenance schedule, yeah, we have one. You got to have one. Pick whatever makes sense for you. Job scheduling, the way we've done it to date, we kind of have this illusion of faculty to have their cluster, right? That because they're spending equipment money, right? They see it as, well, I bought 4 nodes, those 4 are mine, right? And that might actually be backed up with some stipulations and grants and things like that. We're trying to move away from that, especially for the folks that have, smaller resources. When you've only got 1 or 2 nodes, if there's a problem with that specific node, that's a huge deal for them, right? We're managing 1,500 nodes, trying to keep that particular one alive is far more difficult. Let's see, what other kind of things would be good to highlight in here? It's not in this document. I'm sure we've got it somewhere else. I'd have to dig it up, but we have a couple of different tiers of scheduling, a couple of different queues that people have access to. One of the things that we are really quite divergent from the norm is in this queuing piece. So this illusion of every PI's got their own cluster, that might mean they have up to 3, maybe more queues per PI. As we've scaled up over the years, that has really become unwieldy, with our scheduler having, upwards of 100 queues, maybe even more at this point. But conceptually, there's an owner queue. These are my 4 nodes, and I have a queue that runs on those, and that gets the highest priority and all that. We have what we call a hybrid queue, which is their nodes plus that portion that the Institute has purchased to encourage sharing. And then we have kind of a very low priority queue that all participants in the sharing model have access to, and it spans all of their contribution. Right? Moving forward, what we will probably do is something more akin to using the QoS features of Moab to direct jobs to appropriate queues, hardware types, based on the submission of the requirements of the job, right? If that's, that will probably end up in a paper submitted to PERC or something like that in the future. So you can look for that. Storage, we have 3 tiers. Home directory and project, we separate those onto different devices and different protocols just to have some diversity there. Home directories are small, 5 gigs. and are provided by the Institute, PACE budget. Scratch is also separate third device, 7 terabytes per user. The idea is that is high performance, large capacity, and therefore large dollars. But it's also out of the PACE budget. Project is what long-term storage is, and that's what the faculty pay for. So they get to use, however much is they paid for. We have had a couple of instances where people have had lots of small files, millions, tens of millions in one directory. And that just slows everything way, way down. So we've had to put some caps on that. We do backups on project and home, and that just happens. Generally, people don't get to say no, but they also don't pay for it. We made that decision as an institute a while ago that we wanted to protect institute's data. And we wanted to protect that intellectual property asset, right? So we knew that given a choice, there are faculty that would choose not to do that, especially if it's something that they had to pay for. So we said, we're just going to do that. Let me pause there and see if there's a question.
Yes, I have a question. So we at NMSU kind of have like a small cluster. It's around 40 nodes, but we are basically expanding every year by a little bit. We do not have sustainable budget. So we basically grow by condominium model. And we're getting to the point where we do not have any money to like extend the warranty to our hardware and things like that. So I was wondering if any of the other institutions we're thinking into charging for like storage or CPU hours or something like that to get some funding to be able to extend the hardware life.
So at Cornell, we do that. All of our computational services and storage are cost recovery basis, because at Cornell, nothing is free. So we have a subsidy from the Vice Provost for Research, and we basically charge the cost of our people and depreciation minus the subsidy applied. And we're able to actually be quite competitive with, we run an on-prem cloud, but we're able to be quite competitive with AWS, which is the general thing that people want to compare us to. So I can provide more details on that at a later time if that's helpful for folks.
Yeah, sure. If you can just put the link and I'll check the prices. And then I have another question. So Neil, you said that backups are for free at your institution. So I do not know, here at NMSU right now, we are moving away from the tapes, but the tapes are really costly, and backing up everything, or you said home and projects, would actually be costly. So is your Georgia Tech institution basically, or ICT, their IT department paying for that, or they're just giving you for free, or how does that work?
Right. So I guess maybe one step that I missed in describing PACE. We are a pretty self-contained group, even though we are within central IT. We do all the sysadmin. We do an awful lot of the procurement pieces of it. Our pitch to the faculty is give us an account number and a list of users, and we'll do everything between that and let you know when it's available to use, right? We do get some help on various things, but for the most part, we're self-contained, and that includes the backups too. So we haven't done tape for a long time. We have found it more cost-effective to do disk to disk We're just using a lower performing tier to do the backups, which is essentially ZFS on Linux and running rsync, which I would desperately love if there was something more sophisticated than that. There certainly are some scalability issues, but it's worked well for us in the past, and continues to do so. We are fortunate enough to have a secondary data center on the other side of campus, not our old one, but there was a backup to the old one. So that's where our backups are, and we've got, you know, multiple 40 and 100 gig links back to it, so we've got all the bandwidth that we need. And so that's what we've been doing.
Okay, cool, thank you. And I have just one more quick one. So you said, or in your policy, it says that you give between 5 to 7 terabytes in Scratch for up to 60 days. So what if someone's project needs more time? For example, we give 1 terabyte for 120 days, but we also have like, we create projects for them and we can give them more because projects will like last up to 6 months or maybe even longer. So how do you guys deal with if someone asks for extra time or something like that?
Right. So the intent is that the Scratch storage is to be used for actively running jobs, right? If data needs to persist longer than that, that's where the project tier comes into play, right? So that, you know, a very naive way of describing that is your data set is in your project space. When you want to run the job, you stage it into Scratch, compute on the job, and then copy back any results that you need. In practice, it's far more nuanced than that, of course, but that's the general idea.
Thank you.
I just wanted to say it is 12:58. If Neil, if you can stay on, and if anybody else wants to, there's a couple of questions for you in the chat that that I can read to you if you want, or if you want to take a look. Jayshree asked, how did you get the buy-in for the use of startup funds for purchase of compute nodes? You mentioned that you're engineering school now.
Yeah. That was really driven by them, actually. That's not something we went out and sought out. Sort of to fully answer that question, I got to go back to 2009 briefly. We convened this group of high-end HPC users on campus, kind of redefined what the model was. That's when we did the conversion from everybody having clusters and closets to centralizing into a data center. So at that point, we had to develop a bunch of policies that were very accommodating to the faculty, in the sense of, if we don't give something really, really attractive, they won't come into the model. And the administration at the time was not willing to bring the golden hammer and give the thou shalt, right? And we didn't want them to either. So the way we had to do it was buy the equipment and then hire the people, which, if you have opportunity, don't ever do it that way. Don't ever do it that way. We spent the next 6 or 8 years trying to dig ourselves out of that hole, where everything was just slapped together as quick as we could do it, you know, baling twine, bubble gum, duct tape kind of stuff. And it's only recently we've been able to kind of dig out of that. But that's the way we had to do it. That's the politics of the time. It wouldn't have gone any other way.
Thanks, Neil.
Sure. let's see.
One of the other things that we have been thinking about is like a tiered storage system. So something for active storage and backup in cloud and also on-site backup. Do you have like do you have a white paper or things that you submitted to your leadership or whoever it is on how your strategy was for the storage? I'm only asking for what we're working on right now.
Yeah. I don't think we have anything current now. Sorry.
No worries. Can we then, like, aside from this chat, can we chat for a little bit and I can like walk you through the storage plan that we have?
Yeah. Absolutely.
I had one more question for Neil. You mentioned that you had more than you had these queues for each owners, and that started growing. That's where we are now. We started giving each individual owner their own queue, and then now Slurm is looking at 25 queues or 20 queues for each. And as each person buys their node, even if it's a single node, we create a queue, and then it's kind of delaying everything. So if you're going to write a paper, or if you have some things that you've looked at and you want to share, you can share later. That would be really useful, because we're trying to figure out how we're going to make this less cumbersome on us and on Slurm. So we want to bring it down to like 5 or maybe 4 partitions.
Right. So yeah, this is something that is yet to be really detailed to our own faculty. But where we're headed is essentially a queue for each type of hardware, which will bring us down to, I don't know, we'll say less than 10. Different resource types, large memory, local disk, a couple of flavors of GPU, that sort of thing. In Moab, we'll implement that as a QoS rather than an actual queue, I understand. And then we'll use the submit filter to place jobs in the lowest cost QoS that will satisfy the request of the job. Right. So from a user perspective, there is no queue. You just submit it, right? So it simplifies that a little bit. We got to have them submit their job with an account number, to track the costs. But we can have the system decide where the lowest cost is. And that opens some interesting opportunities that we'll explore in the future about hybrid cloud, right? Can we send a certain category of job off to AWS or GCP or whatever, right? If we can figure out how to solve the data movement problem, that might be a pretty viable way to do things. So that's something to a future work, we'll say. Let's see, are there any other questions?
Well, just along that whole condo, the CARC is having a all track session in August during the systems facing track call. And it's all about condos and colos and how they're managed. And so I think that would be, I'm gonna suggest that be one of the topics, is the queues and the scheduling. But that is on August 20th. I believe, the systems facing track call. I'll send that out when I send out the queue up to this or the end of this meeting. But I think that's going to be a really good session, and we did make it for an hour and a half because we anticipate that there will be lots of different discussions about that. I think the other question was about backups. Neil and
Claire, yeah, I see that. We have nearly 100% uptake. And that's not hard to achieve when we don't really give people a choice. Having said that, we are not backing up the scratch space, right? So we do have a couple of edge cases from people that were, I guess one good example is a turbulence guy in aerospace engineering. His code scales up really well. So, you know, he's running on thousands of cores, and he does checkpointing. And those checkpoints can get big, and they were, you know, a little more than we could do on Scratch. So they have a section of their project space that we don't back up, and that's where they write their checkpoints. Right. We have a couple of similar kinds of cases. A bio one that writes boot scoodles of you know, small 64 byte or something insane like that files. That's what the code does, so we need to accommodate it somehow. But that having the presence of those mean we can't get backups done. You know, daily backups take 3 days to complete. So we have a couple of places where we treat it specially, but otherwise everybody just gets backed up.
So nobody's keeping it on thumb drives and servers and.
Well, if they are, I'm sure they are at some point, but that is outside of our environment.
Well, that's true. Right.
Right.
So you're not talking about all research storage. You're talking about research storage related to computation, really.
Right. This is the high performance storage that is attached to our HPC systems.
Mm-hmm. Yes, that's different.
So something that is new for us is an archive tier. And that we are making available to anybody on campus, whether they're a PACE user or not, at, you know, 40 terabytes, $40 per terabyte per year. And we've got essentially it's Swift stack underneath. So we're able to cobble together a lot of old hardware and, you know, crank up the redundancy. So it's survivable, and then we front that with Globus, and we have a nifty. Essentially, it's an HSM type product in between there that caches some things on an NFS server just for speed of ingest, and then, you know, stages the data out to Swift. But that way people can just move stuff back and forth as needed with Globus. And, you know, we tie into a couple of instruments on campus that way as well. You know, sequencers and wind tunnels and, you know, all that kind of stuff.
That's interesting. Well, would you, I don't think we have any more questions. Would you mind sharing your presentation, Neil?
Sure.
If you want to email it to me, I can put it on the shared in the Google folder, and then I'll just send a link out to it. That would be great. That would be good.
Yep.
So I think we probably have taken up enough of your time. It's 1:10. Does anybody else have any last questions, or you know, you can contact Neil directly, or you can contact Rich. Everybody's information's in that sheet, which is great, and that's what we're doing, is trying to create this community. So really appreciate your time, Neil, and
thanks for having me.
Yeah, hopefully you'll come back another time.
Thanks for arranging it. It's really interesting.
Yes.
Thanks, everybody.
Okay.
Great. Thank you.
All right.
Bye-bye.
One.
Thanks
Bye.
all. Bye.